Xn is a sequence of independent random variables with probability distribution. This the value of the limit. Okay. Okay, I see. Maybe this can be a problem of Okay, this is a problem of CLT. Anyways, yeah, I think it's a problem of CLT, not yes, but it's okay. It's like theorem. Let's understand this. You can see this is uniform distribution. So xi are all uniform 0, comma 1, right? Let's understand how I'm thinking. So therefore, log of xi. Do you know the distribution of log of xi? Anyone?
So minus ln xi will follow exponential 1.
Great, super. Why? You can prove it because if you remember, exponential 1 has fx, e to the power minus e to the power minus e to the power minus x. E to the power minus x, sorry. 1 minus, wait, I'm doing some mistake. Exponential का expectation क्या है? Fx, e to the power minus x. So, do you remember? What is the fx of exponential?
So 1 minus.
Yeah, 1 minus e to the power minus x. Okay. So, therefore, xi follows. So, essentially, 1 minus e to the power minus xi. I am doing some mistake. Oh no. 1 minus e to the power minus will follow uniform 0, 1. Okay. So therefore, minus e to the power minus xi will follow. So you can just change now. 1 minus e to the power minus xi will follow uniform 0, 1. So 1 minus uniform 0, 1. So therefore is equivalent to e to the power minus xi. Right. Now this 1 minus uniform 0, 1 also follows uniform 0, 1. Right. So therefore e to the power minus xi follows uniform 0, 1. 1 minus uniform 0, 1 is also follows uniform 0, 1. So therefore, these are all one-to-one equations. That's why it's happening. So if you take log on both sides, here it will become minus xi if you take ln, and here it will become uniform 0, 1. So ln of uniform 0, 1, and then if you put minus on the other side, will follow exponential, that is xi, right? Did you understand the idea, guys? Yeah, all of you? Since they're all one-to-one, functions, that's why it's happening. So minus log xi follows exponential 1. So let's call minus log xi as yi. So this expression is nothing but limit n tends to infinity. What is happening? Anyways, 1 by n summation of I to 1 to n yi. What is happening? Anyways, 1 plus 1 by, okay. So this is nothing but yn bar, and this is something like xn. So by central limit theorem, we know. So this is nothing but nothing but limit f of yn bar of xn, right? Now we know that yn bar converges in probability to normal 0, 1. Sorry. So therefore we need to make some changes here so that it turns out to be normal 0, 1. So central limit theorem does not say this. Central limit theorem says yn bar minus the mu of y by sigma of y by root n. You have to include this here, right? We didn't include this here. That's why weird result will come up if you don't do this. So you have to normalize it. So yn bar minus mu of y by sigma y by root n is less than equal to xn, that is 1 plus 1 by root n minus mu of y by sigma y by root n. Now yi follows exponential 1. So mu of y will be what and sigma of y will be what? Please tell me quickly. Please tell me quickly. What will be what? Both 1. Great. So therefore, let's put it here, 1 and 1 here. So this cancels and this cancels. So it's 1. So it's equivalent to limit f of yn minus mu by that stuff. Let's call that fn of 1, where fn is the distribution function of, right? So therefore, by central limit theorem, limit n tends to infinity, fn of 1 will go to phi of 1. Right? All of you understood this proof? Very easy stuff. Basic CLT. So they use us mostly problems from CLT only. Okay, and WLLN. Or in congruence and probability is important because they're used for consistency. X1, X2, Xn follows is a random sample from uniforms. This and then Y1 or Yn is a random sample from uniform 0, 1. And they are independent. So there is defined if 1 if x1 x2 x. So you can understand easily what to do. So this term automatically implies you have to use WL. So they uses WL and just basic stuff is WL. Remember that. Just use applications WL and CLN. That's it. So therefore, this theta must be expectation of Zi, right? Or limit of expectation of Zi. It will be expectation of Zi of by this because Zi are all similar distribution, right? All of you understood this. So let's find out the Zi. So we have to find expectation of Zi. So therefore, we have to find expectation. So it's, Zi is nothing but what? Zi is indicator random variable xi yi less than 1. So therefore, expectation of Zi must be equal to probability xi yi less than 1. Understand pro x, this is a boundary random variable with this event. So therefore, expectation of Zi will be happening with this probability. Let's find the expectation of Zi. It's very easy. I mean, probability xi less yi less than 1, you know this. So probability less than 1, right? So how do you find this? You can do it easily. Any ideas? This is what? This is f of xi yi of 1. Now xi yi are independent. So you can write this as, can you write this like this? No, because it's not xy comma yi, okay? It's not xy comma yi. Xy less than not. It's not equivalent to that. Yeah. So now we have to understand how to understand this distribution, okay? So xi yi, understand this. So xi yi less than 1. So xi is uniform 1 to 2. Oops. Understand this very carefully. It's all geometry and basic stuff. And this is nothing but 0 to 1. So xi are independent. So they are perpendicular. So it's asking xi is less than 1. That means this is x, this is y, let's say. Am I doing correctly? Yes. So asking area under the curve, you know this passes through this point of xy less than 1. Oops, I did a mistake. Let me draw this curve here. So I can draw good stuff because I have borrowed an iPad from the library. I love to draw things beautifully. So understand that it's area under this curve within this domain, the support. The support is this, right? The support is this stuff. This is the support, right? So therefore, it's asking what the area under the curve between this region of this curve is nothing but x, y is equal to 1. That is y is equal to 1 by x. So it's integration 1 to 2, 1 by x dx. That is ln2 minus ln1. That is ln2.